Hello everyone. What you are looking at is the new Wonderware InTouch Operations Management Interface, or OMI. We've implemented OMI here as an example to monitor a coal mining enterprise, and we call it WonderMine. Our WonderMine operates two different sites, and each site has its own independent beneficiation plant. We're looking here at an overview of the entire enterprise. And one of the most notable features of this interface is the implementation of situational awareness concepts. The entire interface is designed to not only supply you the most important information, but also to assist the viewer to interpret information by indicating desired operating points and ranges, and it will also draw the viewer's attention to any potential problems or abnormal conditions. Another feature of OMI is the context-driven convergence of information from various sources. Now, all that this means is that OMI understands which asset or group of assets is currently the focus, and it will provide all the relevant information in context of that focus. For instance, we are looking at the entire enterprise, so we get all the information aggregated and collected for the entire enterprise. If we zoom in a little bit to the top left panel, we can see we have a summary there of the production for the entire enterprise. A simple pie chart shows the 24-hour production against target values, and where deviations exceed tolerances, that value is brought to the viewer's attention. Of course, InTouch OMI can still be used as a human-machine interface, or HMI, to collect information directly from PLCs and DCSs. By condensing and massaging this information, the viewer is presented with a summarized view of the health of all of the main groups of assets on both sides. The use of the spider chart or polar plot allows the viewer to easily identify whether specific assets are at their expected health status or not, without actually knowing any detail of these assets or how they really operate. If anything requires attention, the interface will demand it with visual cues and the effective use of color. As mentioned before, OMI brings information to the screen from various sources, including those not traditionally associated with human-machine interfaces. Here we have information regarding the health and safety KPIs for the entire enterprise. Incident rates and injury-free operation times are indicated, and the focus is drawn to figures that need a little bit of attention, or even a lot of attention. OMI first indicates to the viewer that there's a possible incident that has occurred, and then, when the safety system reports the reset of the timers, the viewer is made aware that this figure is now a priority. The contextualization of information allows us to add information from other enterprise systems, such as order and contract systems. Completed orders and fulfilled contracts are shown on the left with the contract tonnages. They are matched to the shipping contracts on the right, as well as how much the actual load deviates from the contracted value. An easily understandable deviation chart is also shown on the right for the last couple of contracts. At the bottom left, we see another important aspect of the enterprise, the consumption of utilities. The interface shows us electricity usage, water consumption, as well as control air consumption. And the viewer can easily read the instantaneous usage, as well as the shift daily and monthly consumptions. It's also easy to see if these values are in the expected ranges or whether they require attention. Besides information acquired from our own IT and OT systems, OMI will also allow us to acquire information from public systems, and it will contextualize it directly in terms of the selected asset. For instance, we can draw information directly from the various environmental protection agencies and aggregate it for the enterprise, giving the viewer immediate insight into the environmental conditions at each site. Another feature of OMI is the native touchscreen capabilities. OMI is fully touch aware, and this allows us to use features like a three-fingered swipe to swipe in panels from the edges of the screen. For instance, here a three-fingered swipe to the left will bring the security panel into view, and this will allow the user to log in, to log out, change user, or view information about user. Additional information about alarms or whatever is deemed appropriate can also be displayed on this panel. A three-fingered swipe to the right will hide the panel again. Swiping three fingers to the right again will give us the left-hand panel, this time with a navigation tree on it. Expanding the navigation tree by simply tapping a little plus will allow the user to drill through the hierarchy and navigate to any part thereof. For instance, to access one of the two sites, one simply has to tap on it. The focus now changes to the selected site, and the viewer is presented with information related to this specific site. Using a simple wireframe, the viewer is presented with an overview of the entire site. During normal operation, the overview is designed not to distract, but the moment an abnormal condition is detected, the user is alerted by the effective use of color. For instance, this belt misalignment. OMI presents the relevant information, and since this panel has zooming and panning capabilities, the user can zoom into problematic areas using the touchscreen pinch zoom feature. Two fingers will allow the user to pan around on the site. OMI understands the zoom level and can start to add more detail to the plant as the zoom level increases, which will allow you to declutter the interface as we zoom out and provide more information as we zoom in. The interface not only shows information obtained from the normal control and instrumentation system, but information can also be augmented from other systems. For instance, both the drums and the cyclones are being monitored by our predictive analytics software called Prism, and Prism will look at all the measured values on a specific device. So on the drum, it's measuring the speeds, the vibrations, temperatures, weight, and even the sounds. It then determines the relationships between these values during the normal operation modes of a healthy drum. When it detects anomalies in these values or in their relationships, it will notify the viewer of these anomalies and potential problems, even if it hasn't seen a problem before. If it actually has seen this problem and can identify it, it will diagnose the machine for you, such as this cyclone. It can actually predict the exact failure and warn the user of it in time. It can even predict the exact time of the failure. Since our selected asset is now a specific site, OMI will report the production values for this site only, using the same interface we saw before for the enterprise. The health and safety interface is also familiar, but only shows the information relevant to the selected site, and so do the utility panels. On the site view, additional information appears for the important sub-areas of the site. The separation plant has 2 sub-areas and a panel is dedicated to each, one for the cyclones and one for the drums. Polar plots are used to summarize each of the units, and a set of historical trends show the more important parameters. Historical data is retrieved directly from the Wonderware historian, and another feature of OMI is the capability to play back this historical data. A 3-fingered swipe upwards in our interface will reveal the historical playback panel. Enabling the historical playback panel will freeze the polar plots, as the interface is now effectively paused at that moment in time. The user can directly specify a start and end times and hit the play button to start playing back history. The user can also adjust the playback speed. In paused mode, the user can also drag the slider around to find a specific moment in time to examine. 3 fingers down will get rid of the panel again. On the left, we can also see some tailing dam levels. Because OMI is a powerful convergence platform, it is the ideal front end for stranded assets. The Internet of Things, or more accurately, the Industrial Internet of Things, have enabled sources of information previously unavailable. Collecting dam levels kilometers away from existing infrastructure is no longer a problem, and OMI makes it easy to visualize and can even integrate with most map source providers. OMI allows us to plot live data directly on a map. Different map sources are supported, open source maps being the default, but we can also use other licensed maps such as Bing Maps. It can even use the satellite maps. The map is completely interactive, and on a touchscreen it can be zoomed using a pinch zoom or panning around with 2 fingers. But one can also use a mouse wheel to zoom in and out, and holding that center button down and moving the mouse around will pan around the map. Once again, OMI can add more information as the zoom level is increased. For instance, as the zoom level increases and the dam comes into focus, the de-water pumps are shown. The principles of situational awareness are still adhered to, and the device will draw attention to itself if it needs intervention. For instance, this camera announcing a low battery condition, or the dam level here announcing that the level has become too high or too low. And a low flow condition in this de-water pump is also highlighted. Navigating to the cyclones area will open an overview page with more detail about the cyclone units. The site has 4 cyclones, and the interface again uses polar plots to summarize the most important aspects of each of these cyclones, along with some simple status indicators. The utility usage for the entire cyclones area is also summarized on the left. On the right, we utilize OMI's ability to add the selected asset context to other data sources. In this case, Wonderware's MES performance solution. OMI recognizes that the currently selected asset is the entire group of cyclones, and therefore provides a performance dashboard indicating OEE performance and availability for the entire area. We can also configure OMI to interact with other IT systems like messaging software. Since OMI knows the current asset context, in this case the cyclones area, it can easily determine who the expert is for the area in question. It can then configure the messaging system to put the user in direct contact with the expert. No need to search or ask who to contact when an issue arises. The user can simply start typing to start corresponding with the correct person, and if needed, he can actually hit the voice or video call buttons and connect directly to the expert. In this case, our expert is none other than our own Nilen Bermel, who seems to be quite happy to help us. Thank you, Nilen. OMI also introduces some other navigation methods. Here at the bottom, we find a more detailed faceplate for Cyclone 1. It is, however, not possible to fit this level of detail on the screen for all 4 cyclones. But luckily, you can simply swipe left or right on this panel and access the detail of each of the other cyclones, Cyclone 2, 3, and 4. For more detail on the cyclones, we can navigate to each individual cyclone in the navigation tree. The cyclone detail pages supplies a lot of extra information on the selected cyclone. OMI understands which cyclone is selected, and all the panes are adjusted to show the information regarding the selected cyclone. In the top left, we see a detailed panel indicating the status of the selected cyclone, as well as the production over the last 10 hours and the current operating points and set points. The selected cyclone's utility consumption is also shown, and a simple wireframe diagram is again used to supply the major indicators in the unit. These indicators will also light up and make the user aware of any abnormal conditions. Cyclones are complex devices, and tuning set points to optimize production is not a once-off exercise. For this reason, the solution includes advanced process control in the form of our SimSci S-Core product. The software is used to continuously monitor and tune the unit to optimize performance, and a couple of trends are shown on the screen. For reporting and dashboard purposes, the solution included the Flow software solution. Flow provides us an operational data store and some very nice dashboarding, and since OMI knows the selected cyclone, the relevant dashboard can automatically be shown in the left pane. OMI can also integrate with camera solutions, and the pane on the right will show the Cyclone 1 camera. Since we did not really have a coal mine with a camera, we thought you would enjoy watching this beach-facing webcam instead. At the bottom of the screen, we find on the right a direct link to our Avantis maintenance and condition-based monitoring products. OMI recognizes the selected cyclone and displays a schedule for future maintenance, as well as life expectancy and possible ad hoc maintenance windows for this specific cyclone. The pane on the left shows a more detailed faceplate for the selected cyclone, number 1 in this case. The faceplate has been enabled to show another feature of OMI, the ability to change the selected asset. The user can simply swipe up or down to navigate to other cyclones in the area. OMI detects that another asset is in focus, and all of the other panes on the page are adjusted accordingly to reflect the information of this selected cyclone. The flow dashboard, the camera, the maintenance schedule, APC, as well as machine interface and historical trends are all adjusted to the newly selected asset. We hope you enjoyed watching this introduction to Wonderware's new InTouch OMI. If you need more information, please visit our website www.wonderware.co.za. Thank you very much and goodbye.